The following content has been provided by RWTH Aachen University.
All right, welcome everybody to Designing Interactive Systems 1. Today we'll continue the discussion of the history part of the class, and we'll be looking at some of the visions of the future that people used to have that will give us a couple of ideas of where people thought the field was heading, and we'll also take a look at a model of how technology evolves and where it hits the sweet spot sort of in its evolution and when it goes beyond that. Before we start with that, just a few reminders here. I think you're all aware of this, but just in case that you aren't, the midterm is coming up. So happening on December 6th, on Nikolaus, very nice. And be there a little early, and we'll start the exam at 1, so you should be there at 12:45 so we can let you in. And before that, you can just wait in front of the room, and then we'll ask you to enter. It's happening in AH2. Everybody know where that is? Yeah, okay. So the other number, the inscrutable number is 2350/111. So it's in this building complex, in the main building actually here, the old building. There's AH2, 1, 2, and 3 stacked all above each other. So you'll find it there. Exam will go for 60 minutes as always, and we'll give 60 points. So as you go through your exam, it's a good idea to roughly estimate your effort on trying to get to 1 point per minute, right? If you see a question for 1 point and you're thinking about it for 10 minutes, you're not working in the most efficient way for your grade, right? The other thing is that what will be the material that we're covering in the exam is everything we talked about here in class. So the slides, but also what we said about the slides. So, since we expect you guys to be here and or to follow along on the videos, and the assignments that we did, the materials covered in those, and the required readings. Right? The recommended readings, of course, are optional. They will help you to get a better grasp of the material, but we're not going to ask something specifically that's only mentioned in there. Okay. So with that, a quick review of what we did last time. We talked about a couple of different dimensions of user interfaces in a sort of very vague term of sense of dimension. Anybody recall what those dimensions were? Like what? Yeah, go ahead.
0D, for example, is batch processing because you submit your punch card in a single point of time.
Exactly, right. So interaction on a single point of time, that's 0D. That's why it's Nielsen called it that way. You want to go on with 1D maybe? Yeah.
I think 1D was like when you have a command line interface and you enter your command and then you press enter.
Yeah, right. So the idea behind that was that it's 1D because it's essentially, you can imagine as a string of characters, of bytes going back and forth between you at the terminal and the actual program running on the main computer. Especially what that meant that you wouldn't have anything like, full screen editing, moving cursors about, getting a response on every single key press was not part of that, right? Also, of course, no graphical user interface because that came after that. So then we enter sort of the area of 2D, or we call them, or Nielsen called them 2.5D interfaces, which of course are graphical user interfaces. Why is it 2.5? Yeah, go ahead.
Because the windows can go over each other.
Right. We have sort of a stacked 2D view, right? So that's the assumption here. Great. So then we had a couple key systems that we talked about. So these are sort of the equivalents of, the Centre Pompidou or something like, some impressive architecture that was built at some point and that moved things forward in the history of HCI. So what were the key things? What did each of these introduce? Let's start with Sketchpad. What's the, if you have to tell a friend one thing about what Sketchpad did, what nobody else had done before, what would that be? If that feels suspiciously like a midterm exam, that's because that's what it is. So these kinds of things we'd also expect you to know, right? Go ahead.
Drawing 3D models?
Yeah, you were able to actually draw even 3D models. And it started out with simple 2D drawing, which was already a new thing, but it moved all the way onto 3D drawing. But in fact, it wasn't just that it's a drawing application. It was generally seeing this graphical interaction for lots of different purposes, including even programming, right? Programming in a visual sense, like visual coding approach was shown at the end of the video. So first system that actually had a graphical drawing interface for a general-ish purpose, right? We saw these radar air defense systems before, but that's a very sort of dedicated single-use app that you wouldn't use for generally creating content or working with content. There were also a couple other things in Sketchpad, like you can see already that it's possible to reference objects, right? You could change one object, like a master object, and all the objects depending on that object would then change after that. So you had like an alias function if you want. All right, moving on. Still in the 60s, NLS. What was the key news in NLS? I bet you know at least one. NLS, the online system, the mother of all demos. Yeah, go ahead.
Was that like something like, there was definitely video conferencing?
Mm-hmm. Yes, video conferencing, that's right.
Then coupled with that was also like co-editing documents?
Yes, shared editing of a document. And last row, yeah. The mouse, exactly, right? So they did all that, cool collaborative editing by moving cursors around with what they called a mouse. And I love how Engelbart says, like, yeah, I'm sorry about the name. It kind of, it stuck. We didn't come up with anything better. So apart from the mouse, anything else that was sort of new and unique about the interface? Think about the input devices. There was a working console that he was working on that he showed as part of his demo. And yes, he had a keyboard and he had a mouse. Yeah, there was the chording keyboard, is it what it's called, where you have to put down multiple fingers to create chording sequences, right? That's actually still used by court typists every now and then. So they are extremely fast typing on these chording keyboards. So they are really effective, but you have to basically learn it like playing a piano, right? So it's much harder to learn, of course, than a standard keyboard, which we talked about, right? Invisibility in keyboards and stuff like this. All right. So and then we have the alto and the star. What were the key new things we saw there? Yeah, go ahead.
Completely adopting the desktop or the desk metaphor.
Yes. Yeah, desktop metaphor basically was the first time, right? If you look at the NLS from Engelbart, that's not a desktop, right? It doesn't have a graphical representation of files or folders or anything like that. It's still very much a text-based system. Yes, there was some drawing going on, right? He was sketching out even a mouse, and he had what we could call a split view, which was almost like a windowed view, but it wasn't a graphical UI in that sense that it picked up the desktop metaphor with windows, icons, menus, pointers, and all those things. Apart from that, also something changed sort of with the display at the alto and star. Not on a hardware level, you could say. I mean, the display that Engelbart was using was already able to move a cursor around, pixel by pixel, essentially. But if you look at how everything was being rendered on the alto and the star, what was different there? Yeah? Yeah, it was rendered inside Windows, and that meant not just that you could layer them, that's correct, like with the 2.5D view actually coming into place, but also it meant that you are moving away from the idea of a character generator. Old text-based systems would have a character generator somewhere where you could basically display characters really easily, but it wouldn't give you full access to like the pixel-wise memory for drawing your stuff. And on the alto and the star, what you saw is this WYSIWYG editor, right? That actually displayed letters just the way that they would likely come out of the laser printer later. So that was no longer based on a fixed character display that could only render the classic 8-bit sort of computer font, but it would actually render things in italics and bold and smaller and larger. So you're completely moving away from this idea that you have 80 by 24 lines or something like this, and you now move to, all right, I got lots of pixels, and that's where I'm putting my content, whether it's text or graphics or whatnot. All right, and then we moved on to seeing the Apple Lisa. So what was introduced there? What were the new things or the UI changes, innovations that we saw with that? You might remember two things maybe. What about the menus? Lisa, yeah.
They technically use the bit slot and they put the menu in the top.
Right. So they stuck the menu to the top of the screen, and we talked about that. That's more efficient in terms of pure targeting practice, so to say. But the other thing that also was new here was that this thing also used things like autosave, right? I think we looked at autosave and said how that was later brought back by Apple as like the latest and greatest invention when it already actually existed once before. Okay, but still, moving on to the Mac. What was new on the Mac? Yeah, go ahead. Yeah. The prototyping. Yeah, so this user-centered prototyping and iterating over your designs, that actually was something that the Alto and Star project actually established, so to say, right? So there's this reading assignment that you guys should take a look at that talks about the Star user interface and how what they learned from doing this exercise. Now with the Mac, there was yeah, go ahead.
With the Macintosh.
Mm-hmm.
Yeah, it was more than an office device.
Right, right. Mm-hmm. So that actually, I would say, is already true for the Lisa. The Lisa and the Mac were software-wise not too different, really. They were both much more general purpose and designed to take third-party software, which the Alto and Star were not being built to do, right? They were really pure document processing stations. So Lisa and Mac sort of, Apple said, this is it's kind of like the IBM PC that at that time had been out for 3 years maybe, but it is with a graphic user interface, right? Instead of the text-based DOS-based interface that people had gotten used to. Yeah.
I think with the Macintosh they took away the arrow keypad, so you'd be forced to use the mouse.
Right. They did that, and my hunch would be, I'm not sure about this, but that's probably also true for the Lisa. But you could look that up. Check a picture of the Lisa and the keyboard, or maybe dig one out in Utah, find one for yourself, and then you can see that. Yeah, that was an interesting design decision. More of pressuring people into really adopting the mouse as a navigation tool. Yeah.
I think the difference is that the Macintosh was much more affordable than the other ones.
That's actually an important point. Yeah, the price was actually affordable, and so that the Mac turned out to be the world's first commercially successful GUI computer. Right? All the others before had pioneered the ideas. There weren't that many things that were radically different about the Mac user interface. Yes, there were some re-implementations. The Mac was also actually speedy enough so that you could actually work without, unlike the Lisa, because some clever people had implemented lots of the graphics code for the Mac so that in a much more efficient way. So it was fast enough and it was affordable enough so that it actually could take off and became a commercial success. All right. Now, first thing we're going to talk about today is these technology phases. This is based on a model that David Little actually proposed many years ago. He is not an unknown person in the history of HCI. He actually wrote the display controller for the Xerox Alto computer. He was the project lead for the Xerox Star computer. And then he founded, companies like Metaphor and Interval, a think tank of the 90s, and turned to venture capitalism. And he proposed these three phases of technology in an article. I looked at that and I thought, this is almost complete, but I had a feeling that there was something to be added. And that's what I called the Baroque phase back here. We're going to talk about what these 4 phases are then in the end. So the idea of these 4 phases is that when you have a new technology, let's take, for example, GPS, right? It starts out, this new technology starts out getting used in what Little calls the enthusiast phase, where mostly people pick it up because they're nerds, or they're like technically interested, and they want to play with the technology. And so the idea there is that the technology is out there, and it basically says, yeah, I'm complicated, I'm not easy to use or anything like that, but you could do awesome things with it if you just put your mind to it and tinker with it. And I have a picture to show that, which is actually a picture of the dashboard of my own car in San Diego around 2007 maybe. So the iPhone hadn't come out yet, and I had this PDA. Right? This was like a predecessor of your modern smartphone, but it didn't actually have a phone built in. It's just a tiny little computer with a keyboard and screen. And on this tiny little computer was running a navigation software, so you could actually like navigate from A to B, right? This thing is a computer from the 90s. And then I bought a GPS receiver and wired it up with a cable to my PDA, and then it had all to be powered off the car battery, and it needed some antenna stuff. So it was terribly complicated. It looked literally like what you see there. But I was able to actually have this thing tell me where to drive, which was like, whoa, mind blown back in 2007. So this is a typical example of this technology, like the GPS receiver in this case, getting used in a setting that isn't for everyone, right? It's really if you just want to really get down and deal with the technological challenges. Next phase is what Little calls the professional phase. And again, I'm using an example of GPS here. Fleets, GPS, the next step was not that everybody had a navsat in their car, right? The next step was that large truck fleets said, for us, it's so important to know where our drivers are because it's at the core of our business. Yes, the technology is still fiddly and expensive and not packaged up in a nice consumer-friendly way, but we're going to build that into our trucks and train our drivers to use it because it's really worth it, right? So oftentimes technology then gets adopted in this way, and that would be the professional phase, right? It helps people get their job done. And in this setting, of course, since you're getting paid if you're the truck driver to do your job, you're ready to, take a training on how to use these things and spend some time actually getting to grips with it, right? You may not love it, but it's part of your job, so you do it anyway. So usability still isn't high up there on the list because people are kind of forced to use the tech. And so that often ends up being the professional phase of this new technology being introduced. And then the next phase that Little identifies is the consumer phase, where things are supposed to be used in everyday life. And that came around when GPS receivers, like this is an example, I think it's a Garmin model that came out for hikers who could pick up this thing in their outdoor store, turn it on, and it would have a map on there of their area, and it would let them see on a map where they are, and would tell them where to go to navigate to the next point. So at that point, you could say it was starting to enter actually people's personal lives and their private lives. And in that situation, of course, in my personal and private life, especially when it's about these like hobby things, I'm not forced to use this stuff, right? I have a choice. I can pick something. I can pick this or the other. Nothing is being prescribed for me in this case. And so usability actually becomes much more important in the user interface, and the whole user experience has to be much more smooth in order to make this a success. Right? So the key here is that this thing now says like enjoy using me, the system, whatever it does. And so that's where Little stops. He says this is what we often see, what he's often seen in technology happening from this enthusiast to the professional to the consumer phase. When I read his article, I thought that, well, I think there's something missing, because what I think we reach at this point, this is not the end of the evolution, right? At some point, we have what I would call the sweet spot. And the sweet spot is a point at which the devices get to this perfect mix of functionality and simplicity, where suddenly, everybody wants one. And I think that happened for GPSs around the time TomTom, the company, made their sort of all-in-one navigation devices, right? I mean, Garmin did something similar, but they were pretty big here, especially in the EU, but also in the US, and they were, you could go to, MediaMarkt, buy one, stick it in the front shield of your car at the windshield, turn it on and tell it where you want to go, and it would take you there, right? That's such a clear value proposition in such a smooth user experience, and no fiddling with tons of cables. These things had a battery that you only had to charge occasionally. No multiple devices to wire up. It's just literally, a rubber suction cup, and off you go. And all of that, plus, of course, it's now a color screen. It's got a reasonable resolution. It has a 3D view, oriented the way that you might want it to in your driving direction. All these kinds of things that these things you didn't have yet for various reasons. And so that, I think, is the sweet spot. And now, but unfortunately, you could say, oftentimes in the history of these device technologies, this is still not where things stop. What we see after that is often what I would call the Baroque phase. And the Baroque phase, Baroque, the style back then was like, lots of gold and decoration on everything, right? And that's kind of what we see in devices too. So there was actually a version of, once everybody had a TomTom in their car, TomTom was like, oh crap, what do we do now? What's our business model, right? And so they kept adding new functionality to the new models that was more and more, or less and less relevant to their core idea of getting people from A to B safely, right? In fact, there was one version of the TomTom device that would actually have a photo slideshow viewer on the device of something you're using while you're hurtling down the Autobahn at 150 kilometers an hour, right? So probably not the greatest idea, but why was this going on? Well, I wasn't at the meeting, but I'm imagining it goes something like that. Hey guys, what else could we do with this thing? Well, it's a computer, we can program it, we're computer scientists, we're engineers, we're developers. I could put a photo viewer on it. Sounds like a good idea, let's do it, right? So that's the problem, it's a computer, right? And so when it's a computer, you can do anything with it, right? It's general purpose computing device. It has a screen, it has touch input, off you go, right? So at that point, it's very, very tempting to just do other things with this. But I mean, you might say, well, it doesn't hurt, right? I don't need to use the actual screen viewer, but it's not that simple. When you look at the start page of the TomTom, when you turn it on, as you were adding all these extra things, the screen got more crowded, there were more options, and it became harder and harder to actually find the key thing that it was made to do, right? Just getting from A to B. So this Baroque phase is something that I think technology often tends to drive into because of market forces, but it's usually not necessarily in the interest of usability and actual usefulness of the technology itself. All right, so here's another example, just to explain this in a different view. Let's take cell phones, right? So in the mid-90s, you could get a receiver. You could probably order some circuitry that would let you build a cell phone, and then it was really for hackers and hobbyists only. But we know that it then took off with these things. Right? This is a phone inside a suitcase, right? That you could buy, but you would say like, I'm not going to carry that around to university, right? And no, you wouldn't. But people who were on the road all day because they were driving around in their cars, going from whatever, one construction site to the next or something, and needed to be in contact with their office, it made sense professionally, right? So they would deal with these things and even though they were heavy, right, and cumbersome. And then, of course, we know the consumer phase started when these things became small enough so that you could, well, you don't want to pocket this thing, but generally you could carry it around with you without, being looking completely like an idiot. And then, of course, for cell phones, I'm not saying smartphones here, right? I'm saying cell phones, which is calling, texting, right? That's it. For cell phones, I'd say the sweet spot was somewhere around this, right? The Nokia early, like not early, but the sort of pretty actually mature, simple, dumb phones, as we called them later on. They weren't that dumb though, right? They were really good at doing what they were supposed to do. And I remember having one of those, and like the battery just wouldn't run out, right? You could use this thing for like days and it wouldn't die. Not at all like our today's smartphones, by the way. And what this did is that what you noticed was cell phones. I'm not sure whether you're aware of this, but there was a time I would go to conferences a lot, right? And one of the biggest challenges of going to a conference was when the conference was wrapping up for the day, people would be like, all right, so where are we going to go tonight, for dinner or something? And then people would be like, yeah, I think there's this place over there. You're in a new town, right? You don't know your way around. There's this new place that I heard that is cool. Let's go there. Okay, when? I don't know, maybe 8. And so everybody had to agree on like a time and place at which they would actually meet at a certain location. I know that sounds very alien to you guys, right? But that was what had to go on. And if you didn't exchange that information, you were out for the evening, right? There was no way to reach these people. And that's completely changed, of course, right? Nowadays, you're like, yeah, whatever. And people change their mind 15 times over the course of the evening. Not necessarily better, but it's a different way of communicating. And it has, of course, improved and smoothed out all these things so much. And also, another source of agony that you'll never experience if you have a cell phone is this, like, you go into like a large, I don't know, meeting or whatever, like a concert or something, and then you look for the other person, right? And then you're like, oh, I was looking for you forever. No, I was looking for you all the time. And you can have the best fight ever. Doesn't work anymore, right? You just call each other and there's the solution. And so that, I think, was all became possible because the cell phone became ubiquitous. And then we saw the Baroque phase. And the Baroque phase looked something like this. This is, I think, from an HP and iPac, one of these supposedly smartphones, but still trying to cram everything. Do you notice how this looks suspiciously like a desktop UI, right? That's because that's what it was, essentially, right? They just shrunk down the desktop UI and said, I can put this on this tiny screen. I'm going to give you this tiny little pointer device, and you can try to hit the right icons with it, and then we got tiny little buttons down there. So why was this going on? Because people were trying to put more and more functions into the cell phone. So we were entering a Baroque phase. And now you can also see how you can possibly get out of the Baroque phase, because, of course, it's not the end, right? So what needs to happen then is the reinvention of this technology, or the invention of a new technology or form factor that then allows this new functionality to actually make sense and become simple again, right? And that, of course, then ultimately was today's smartphone, right? The touchscreen, the iPhone, and all these other things that happened that cleaned up this mess, right? That said, okay, if you want to do all these things with this device, we got to go for a different form factor. We got to rethink what this was, right? We're not going to just live with this and try to cram more and more things onto it. We need to change the design. And we ran studies for Connect, the German magazine, years ago on these devices, and asked people to just place a call, and they would always fail. And the Baroque phase, right? The sweet spot is something that tends to simplify your life. It gives you a new kind of support, right? Think of like a TomTom in your car or a cell phone in your pocket. You have to learn a few things to use it, but there is a magical boost to your life, right? It really changes how you go about your everyday lives. Whereas the Baroque things, it's more like it's tweaking existing processes. It tries to make things more efficient, but it often complicates some of the tasks, and sometimes even crucial ones, like calling somebody on one of these iPacs, for example. Or think microwave, right? It's another example where the Baroque, the sweet spot has been reached long ago with microwaves, and what you see today is kind of ridiculous. And you have to learn many new concepts in the Baroque phase in order to get the extra payoff out of it, right? Okay, so for this, that is sort of the idea of what I think the sweet spot in the Baroque phase add to this model that David Little proposed. We are at a time where we can move on to the HCI visions, and that is sort of a series of short videos around which we will talk about some of the ideas that people had for the future sort of development of interfaces. Let's start with the first, an idea of what I want you guys to take away from this. Right? These visions are, we've selected a few trends here. Of course, there are lots of different views of how the future would play out. So three ways in which I would like you guys to look at this. The first thing is to look at it from the author's point of view, right? The guys who wrote these papers or made these videos had some key new idea that they wanted to get across, right? So I would like you guys to identify that and maybe take out a piece of paper and write that down for yourself, so that you know, okay, that's the key new thing that I'm seeing while I'm watching this video. The second thing I want you guys to think about is, how was it actually communicated? What did they do to get the idea across? Did they just, make a thing and are holding it in the camera and talking about it? Or did they create a little story around it? Are they making somebody else use it? Does it look like a realistic use, or is it more like a tech demo of the developer? Are they communicating just the benefits of it, or also some challenges of using it and potential problems? What's their approach to get it across? And did they actually even build it? What did they build? Did they go ahead and implement it all, or did they just do a paper prototype and film that? What was going on there? Can you tell? If it's really done well, you may not even be able to tell exactly what the prototype was made of. The second area I want you guys to think about is the audience's point of view. So it's going to be a little tough, but I need you guys to sort of take yourselves back to the time when this video was released and think about, what do you think the audience at that time had been exposed to, and what was their likely reaction to it? Like, what would have been what would have been provoked in the audience, in both a positive and a negative point of view, right? So were there any advantages or new ideas that would have blown everybody away, or would people have reacted maybe suspiciously towards this new technology? And finally, that should be easier from today's point of view. Look at what's being proposed in these vision videos, and then tell us, is that standard today? So has that vision become true, in the sense that, yes, that's exactly what we're doing today? Or is it maybe not the case that everybody is doing today what they were proposing? And if it's not the case, then why? Have we moved in a different direction instead? Have we just worked our way around the problem that they were trying to solve? Did we solve it in a different way? Or have we still not gotten there? It's also possible, right? They could have a vision, and they were like imagining that by the year 2005 everybody would be doing this, and here we are 20 years later, and we're still not able to do that, right? So that's also where you will see some differences. All right, we're going to start with an early video about multimodality. Multimodality means using more than one mode of interaction, and this thing is called Put That There. It was done by Chris Schmont and at MIT in the 80s. And so the key advances here that you'll see is gesture recognition and combining voice and other input modes. So I'm going to give that away for you, but I'd like you to pay attention to the interactions here, how they're happening, and what are the assumptions here of what the computer system is doing, what is actually going on, who is understanding how much of spoken language, etc. All right, let me roll that video. And this is two engineers, acting as users in this one. So excuse the bad acting, okay? I should explain maybe what's going on here, because this is sometimes a little hard to grasp in the first moment. There's a person here in front of a map of the Caribbean, and he is moving ships around on this map, right? That's the basic idea. and then a second person will join him later, and they are going to be trying to do that that same thing with 2 people. So that's what you're going to see here. And there's a computer that he's talking to, and that computer talks back in a funny voice.
Welcome to the Caribbean. I'm waiting for you.
Pay attention.
Go ahead.
Create a red oil tanker.
Where?
There. Put a blue cruise ship
Where?
east of the Bahamas. Make a yellow sailboat
Where?
north of that. Create a green freighter
Where?
east of the sailboat. Put that
Where?
there. Move the freighter
Where?
there. Where is Havana?
West Central.
Where is Jamaica?
South Central.
Move the freighter.
What command?
Move
Where?
south of Jamaica. Move the trawler
Where?
east of the sailboat. Move that
Where?
where it was. Copy that
Where?
there. Change that to yellow.
What command?
Change. Copy the cruise ship.
What command?
Copy.
Where?
South of Havana. Make that small. Make that what it was. Move that
Where?
there.
Well, Chris, looks like we're back here in the Caribbean.
Sure does, Eric. Let's put some ships in it.
Let's give it a try. Pay attention.
Go ahead.
Create a red oil tanker
Where?
there.
Create a blue cruise ship
Where?
there.
Make a yellow sailboat
What color?
yellow
Where?
north of Jamaica.
Create a green freighter
Where?
north of that.
Let's try one together.
Sure, let's try it. Clear. Clear.
Proceed.
Put that there. Protect that.
Copy the cruise ship.
Eric, do you agree?
That's acceptable.
Thank you.
Where?
North of the Dominican Republic.
Protect that.
Protect the freighter.
Copy the freighter.
Chris, do you agree?
No way.
Thanks a heap.
You also?
All right. Okay. So, what was special about the interactions here? What kind of capabilities were these guys assuming or using? What do you think? Yeah, last row. Yeah, so there was certainly speech recognition going on. Was it speech recognition like how you talk to, Siri or Alexa or Google today? Yeah. Yeah. So this was very structured commands, where they were thinking hard about how to say it, and you may have noticed there was a special attention phrase too that he said at the beginning. Pay attention and stuff like this, so to enable it. Later on, however, they were talking to each other and then saying things to the computer. So in some ways, the computer was ignoring things that were being said among the two folks. So it was sort of following the conversation a bit. All right, so in some way a little weaker than what we have today with the sort of continuous speech recognition with lots of different ways of saying something. What about the state of the interaction and the speech recognition? Was the system aware of the history of what had been done? Yeah?
Yes, because you were able to redo stuff.
Right.
And you also, you combined the speech recognition with the gestures, because you could say stuff like there, and combine your gesture with what you are saying.
Exactly. So right on both points. First of all, yes, there was history going on, and not just undo this last command like we do today in like Photoshop or something, but actually much later saying put that back where it was, right? So it knew that this thing had been moved there at some earlier stage, and it was able to remember that that recent position could now get basically restored. And you're right also, and this is maybe the most important thing here about put that there. Is literally in the title, right? Being able to say, put that there, and at the same time issuing pointing commands to different points on the screen with their hand. And there was a tracker on the finger, right? That was tracking things in space. That is probably the biggest HCI-wise challenge here, apart from, of course, speech recognition. Because think about it, right? Imagine yourself writing a tool like this. So you are getting speech input, which is kind of tricky enough by itself, and now you're also getting XY coordinates of things being pointed to. How do you define, okay, do I have to point to something before or during saying it or after saying it? How do I map gestures to spoken commands, right? How do I do that? And they even were able to do that with two people. So there was quite a lot of going on of synchronizing these different input streams, these different modalities of gesture and voice, in order for the system to sort of do what you would expect it to do. And this is a great example of, it felt actually, apart from the bad acting and the weird computer voice, it felt pretty natural, right? It's like, put that there. That's probably roughly how I would ask you to move something from A to B, right? If you are decorating the Christmas tree, can you put that thing over there? And so we humans do this all the time, right? We combine our modalities for interaction. And a computer really has to work pretty hard. And I don't know about your smart home setup. I can't do that at home right now. So that hasn't happened yet in that general sense. Yes, there are systems that will let you recognize gestures if you're playing a game or something like this, but it hasn't sort of become part of our everyday life setup like the voice assistants have. So interesting combinations here. So you could say, yeah, this speech recognition has definitely superseded what we see here. And kudos to these folks that they were actually apparently, at least that's what it looks like, running a real system doing its thing, right? So that wasn't just a fake recording. They also had some failure states in there, if you noticed, right? So occasionally system would not recognize something and would ask back, which shows that it was able to actually recover from a misunderstanding, which is one of the biggest things that we're still failing with today. If you talk to your smart home voice assistant or something and it doesn't get anything, then it gets really hairy really quickly, right, to recover from that. All right, so let's put that there. Let's look at one more. The next one, so this was in 1980, I think. And And so remember, again, it's important. This is why we do the history thing. Right? You can now understand what it means to be in 1980 from an HCI point of view. Like the IBM PC hadn't even happened yet, right? The Xerox Star had been, was on its way out, but hadn't happened yet either, right? The Alto was out there, but it wasn't really a big success. So apart from a few people visiting Xerox, probably nobody had seen it. And on the research track here, this comes along, right, and says like, hey, why not just point and talk to the computer? And so we're again seeing these two lines, right? Research going way ahead with its ideas, and until it actually hits commercial products, it takes a long time to filter down that line, and that's just the way of things. We're going to see another video called the Knowledge Navigator. This was done in 1988 by Apple. And this is a mock-up, so not actually implemented, but it's a vision video mock-up. And you'll see that their key idea was to get people excited about user agents, so things on the computer, helping you, assisting you in a fairly human form. You will see this guy actually becoming the computer assistant in this. Also multimedia. Multimedia was very big back then in the late 80s, early 90s, when everybody, PCs by that time, and the Mac had been out, Windows had caught up, and people were starting to add things like graphics, video, audio to their computer capabilities. So multimedia was a big story. Right, I'm just going to play this video. Again, the story backdrop here, so you're not completely lost, is you're going to be watching a professor who is actually a professor of geology or biology, yeah, probably geology, something like that, who's in his office, and he's getting some calls, he's planning a class, he's talking to a colleague, these kinds of things. And he also has some private business to take care of. And you'll see this playing out in him interacting with this fake model here of the Knowledge Navigator. This is sort of his personal device that he's using. Feels a little bit like what you would have on your like a mix between a laptop and an iPad maybe today, but we'll see. Also a little bit different production quality, you will notice. So when you don't have a bunch of hippie researchers in a research lab trying to make a demo video, but you actually have a company throwing lots of money at the problem, then it looks a little different.
You have 3 messages. Your graduate research team in Guatemala, just checking in. Robert Jordan, a second semester junior, requesting a second extension on his term paper. And your mother reminding you about your father's
surprise birthday party next Sunday.
Today you have a faculty lunch at 12 o'clock. You need to take Kathy to the airport by 2. You have a lecture at 4:15 on deforestation in the Amazon rainforest.
Right. Let me see the lecture notes from last semester. No, that's not enough. I need to review more recent literature. Pull up all the new articles I haven't read yet.
Journal articles only?
Fine.
Your friend Jill Gilbert has published an article about deforestation in the Amazon and its effects on rainfall in the sub-Sahara. It also covers drought's effect on food production in Africa and increasing imports of food.
Contact Jill.
I'm sorry, she's not available right now. I left a message that you had called.
Okay. Let's see. There's an article about 5 years ago, Dr. Flemson or something. He really disagreed with the direction of Jill's research.
John Fleming of Uppsala University. He published in the Journal of Earth Science of July 20 of 2006.
Yes, that's it. He was challenging Jill's projection and the amount of carbon dioxide being released to the atmosphere through deforestation. I'd like to recheck his figures.
Here's the rate of deforestation he predicted.
And what happened? He was really off. Give me the university research network. Show only universities with geography nodes. Show Brazil. Copy the last 30 years at this location at 1 month intervals.
Excuse me, Jill Gilbert is calling back.
Great, put her through.
Hi, Mike. What's up?
Jill, thanks for getting back to me. Well, I guess that new grant of yours hasn't dampened your literary abilities. Rumor has it that you've just put out the definitive article on deforestation.
Aha. Is this one of your typical last-minute panics for lecture material?
It would be great if you were available to make a few comments. Nothing formal. After my talk, you would come up on the big screen, discuss your article, and then answer some questions from the class.
You know, I have a simulation that shows the spread of the Sahara over the last 20 years. Here, let me show you.
Nice. Very nice. I've got some maps of the Amazon area during the same time. Let's put these together. Interesting. I can definitely use this. Thanks for your time, Jill. I really appreciate it.
No problem. But next time I'm in Berkeley, you're buying the dinner.
Dinner, right.
See ya, 4:15.
Bye-bye.
While you were busy, your mother called again to remind you to pick up the birthday cake.
Fine. Print this article before I go.
Now printing.
Okay, I'm going to lunch now. If Kathy calls, tell her I'll be there at 2 o'clock. Also, find out if I can set up a meeting tomorrow morning with, Tom Lee.
Enjoy your lunch. Hello, Professor Bradford is away at the moment. Would you like to leave a message?
Michael, this is your mother. I know that you're there. I'm just calling to remind you to call your sister and pick up.
All right. So, a little bit of a different story here, right, from what we saw with Put That There. So what are you, what was unusual here about the interaction? What was new? How was it received? Like, what are your thoughts? And yeah.
I think the main topic that was presented was the convenience of the assistant, which was presented in kind of a humanoid form, which you can interact with in a very natural way. And he understood all commands that the actor gave him, and also was able to ask questions to be more specific or to extend upon the command, and did not really had any failure that was present, so he always understood everything if I didn't miss anything. And he also managed all the communication going on, so he was also kind of a representative for the professor. And he was able to access and refine or analyze all different kinds of data, and was kind of like the non plus ultra research assistant for the professor, because he didn't even need to touch the device, he just had to open it, and it was all booted up instantaneously. And this was kind of his workflow, just talking to the assistant, which was then a very powerful help.
Yes, exactly. Yeah, very well described. Yeah, he opens it up. It has this cool, like, you know, joint display. And until a couple of years ago, everybody in class was like, yeah, and he's folding up this display. And of course, that doesn't work, right? Well, nowadays, you know, you guys have folding smartphones with folding displays in your pocket. So that's gradually happening. But you're right. The key thing here is that this assistant, let's call it, like the knowledge navigator, understands an awful lot about what's going on, right? What would you say, do you remember what was the most sort of, what was the part of the discussion or the dialogue, or the, you know, dialogue, I guess is a good word, that was assuming the most advanced sort of HCI or most advanced features of the system. Yeah.
If there was a part that he was saying, okay, 5 years ago there was a professor named Flamas or something, and it realized it's Professor Flama, or I don't remember the name correctly, but it recognized that the name was wrong and it was someone else.
Yeah. So I think that was the point where something really interesting happened. And yes, correcting the name, I could still buy that, but the next part of it was really astonishing.
But didn't their assistant suggest someone publishing a paper like this? Like assistant himself said something like, "Oh, there was a paper which kind of didn't agree with another paper. If you want to have a look at it."
So this is the interesting part, right? The actor, the professor, says there was a paper by this guy, blah blah blah, Flimson something. He really disagreed with the direction Jill's research was going. And from that, this thing comes back. First of all, yeah, it corrects to like, yeah, it's Professor Fleming or something. But then it also says, he wrote this paper, and so it actually understood what it means to disagree with somebody else in a research paper. AI, right? So that's a problem I call AI complete, right? When you solve that, then you've solved all the problems of AI. Now, I think this is a fairly advanced assumption on text understanding, right? It's not off the charts at this point, right? We can see how that would be possible. And recent advances in deep neural networks and stuff like this have actually gotten us a little closer, maybe, to those kinds of abstract notions. But in 1988, that was not around the corner, right? Not around the corner at all. So that's one thing that I think is pretty obvious about the Knowledge Navigator. It's really, this video makes a lot of assumptions on what technology is going to be able to do. So you can see this was not based on what's already running in research labs around the corner, but it is really trying to say, well, this could be possible, right, if we really make big, big leaps forward. The next short video, this is about a project called Starfire. Starfire was developed as a video prototype of a future system for computing, like your desktop workstation, basically, your workplace, your electronic workplace, but also for communications. There was lots of connecting to other people in this vision of this video. It was developed at Sun, which used to be a company that was one of the big makers of computing hardware. You may still know about Sun. It was later acquired by Oracle. They were behind behind Java, for example. And the person who made this video, though, that's an interesting one, was Bruce Tognazzini. He actually, or nicknamed Tog, was at this point at Sunsoft, Sun Microsystems, running the Human Factors Engineering Group. But he, before that, had been one of the engineer or designers at Apple, designing the Macintosh user interface. So he had moved from Apple to Sun, and his goal was quite different from what the Apple Knowledge Navigator is doing. They wanted to show a system that would be realistic within 10 years. And so what you will hear, if you pay close attention to the beginning, which sets the scene for this video, there's a scene at the airport where this starts out. You will actually hear that the story is supposed to take, and you will see that it was supposed to happen in 2004. So video made in 92 to 94, story placed in 2004. And again, write down what's what is realistic now, what's everyday stuff, what isn't, what's surprising you. To also give you a very rough idea of what's going on. After the airport scene, there will be somebody arriving there, an employee, and then we will see, most of the time we'll see a woman working in an office that is designing cars, electric cars, because this is the future, right? And she, in order to get her design complete, she interacts with a couple different people. She also interacts with her family in between. And then ultimately she makes her presentation in a conference room where she has to defend her design against another competing car design and tries to get hers built first. So most of the time we'll be in this office of that lady, and then later on we'll also be in a futuristic conference room, so a little bit of a different setting. Okay, again, produced professionally, not your average research video, but actually made with quite a bit of care for the details. Also in this one, I want you to pay attention to usability breakdowns, because Tog, being an HCI expert, he wrote a great book, Tog on Interface, which talks about some of the biggest things he learned from throughout designing the Mac user interface and then moving on to other projects. And so he was very aware of that you need to pay attention for these mistakes and slips that people make, and that systems need to deal with that because they will happen, right? That's often being ignored by other designers. So here's a screenshot of what that looks like. The setup that we're going to be seeing. So let's roll the video.
Good afternoon, and I would like to thank you for flying Air Ukrainia's Flight 554, providing a service from Kiev to London.
Princess Di has been reappointed to the House of Lords. For additional details, pick up a copy of the Evening Sun from the newsstand or your personal information space. Your personal desktop is just a few steps away at a Sun Video collaboration booth. For the high-speed train to Paris, please proceed to Terminal D.
Close information space. Answer.
Good morning, Julie. I've been trying to reach you. How are things in Detroit?
Oh, Adrian, we've got trouble.
Oh, what's wrong?
O'Connor? He sent a memo to the executive committee saying our car was going to be late, so his should ship first.
Getting a bit anxious about his bonus. I see.
And Reg called a special meeting this afternoon.
What? I thought he was in L.A.
He is. So, you'll get to whisper in his ear why you've slipped our production schedule 3 weeks.
Look, Julie, I didn't slip anything. Kiev had to enlarge the fuel cell.
I'm sorry. I am just so...
And anyway, the production problem is solved.
What? What did...
Bless you.
No, bless you, Adrian. That's great news.
I pasted in the solution on page 26 of your report. But now that I come to look at it, you may want it over here instead.
Good. I'll tear off a new control panel.
You see, Austin can drop the new fuel cell right into place.
This is wonderful, Adrian. Here's AJ. I got the poor guy up at the crack of dawn. Hi, AJ.
Oh, hi, Julie. Adrian?
Hi, AJ. Do you have our new retro roadster?
Sure do, and it's running smooth as silk. It's so tight.
Bless you. Okay, I'll let you two go. And Julie, take care of that cold.
Bye.
See ya.
Here's the uphill shot with the chart.
Car's a bit far away. But I can take care of that with an auto pan. That should work. Now, I'll need an ending shot. Maybe we could... will you link the camera to me?
Sure.
Let's have the car sweep into view. And as it comes to rest, push in on the wheel.
Can do.
Bye, AJ. Molly got flowers. Okay, Bruce. All those flowers. Can't be Fred.
Honey, have you seen McCormick's column? This is great. Mm-hmm.
Let me scan it. Open report. Insert. As Mike McCormick wrote in his column today. End insert. You know, I'm still struggling with this 3D model.
What's the problem?
It just looks it looks like an engineer did it.
Well, darling, let's dress it up a little bit. Move it up where we can work on it. I came across an old TV ad in the company library. Where is he? There he is.
Hide call-outs. Vellum. Mannequin. Male. 5'11".
6'2".
Texture map. Adobe. Wand. Source. Okay. Let me move him over. Let's see. There.
Light me up the model, will you? I want to nudge the viewpoint just a little.
That's perfect.
Yes.
It is Fred. I wonder. Oh, wow. He finally proposed. Auto pan target.
Bless you, Julie. It's 3:30. Have you taken your cold medicine?
Cut it out.
I'm sorry, Julie. I can't do that.
Bill.
Oh, I'm sorry, hon. Betsy put me up to it.
What? No way, Mom. It was Sam. Was not.
Oh, well, listen, hon. The bank just sent the papers over. The loan was approved, but they need your signature on the truth in lending form. Right here.
There you go.
Thank you. Bye-bye.
Bye, Mom.
Oh, hey, come on, guys. Calm down, all right?
Combined chart and film, sync, and posterize. In conclusion, we are poised to offer the first zero-emission, high-performance sports car in history. The last solar-powered fuel plant went on stream this week. The delivery infrastructure is in place, and as our Austin-Kiev simulation shows, we have passed our last production hurdle. Our first cars hit the showrooms March 26th, and we project shipment of over 5,000 cars per month by the end of spring. Our numbers suggest that total domestic sales volume for the first full modeled year will exceed 80,000 automobiles. In short, we are ready to build a car that will make this company a lot of money now.
What do you say now, Mike?
Very impressive presentation, Julie. However, I have to seriously question these sales figures, Reg. Just look at the DX9 launch in April of '99. It was an unmitigated disaster. And why? Because you cannot launch a sports car in the spring. All you have to do is look at the percentages of exotic cars that end up in California. We've all seen the figures. Californians buy 85% of the exotic cars in this country.
What's that got to do with...
No, Reg, just a minute. Let me run with this. Now, by the time their marketing ramps up, it'll be fall, and that's a best-case scenario. It rains in California in the fall. And when it rains, you cannot sell sports cars. My luxury car, on the other hand, is a year-round car. And we are ready to start production and promotion. I want to launch now. And we can bring out Julie's car in the fall. And she's had time to reassess the...
May I interrupt? First, our PR campaign is in full swing all over the world. Mike McCormick, who is not exactly loose with the compliments, just today called it one of the finest PR campaigns to come out of this town in a long time. As for the DX9 launch, it was hurt, not by season, but by earthquake. The big one of '99 is the real cause for Mr. O'Connor's sluggish sales. But when people calmed down and the highways were reopened, sales soared. In fact, if I slide their line onto our chart, thank you, Adrian, you can see that their run rate at year end is identical to ours. So unless Mr. O'Connor has some early notice of another earthquake, I think we can safely look for sales to explode.
Thanks, Julie. I think we've heard enough. You and your team have done a superlative job. Let's build it. Now, Mike's car. We'll go back to the original production schedule, although, Hiroshi, I believe you had some concerns about Mike's projections and cost and setting up the production line?
Sun Microsystems, the power of the future.
All right. So, what did you notice about this one? What were things that seemed out of place or very much unlike what we do today? Yeah, back there.
Yeah, I found it really confusing that at first they only used gestures to use the device, and then they started using completely other things, voice controls and also a mouse, a hardware mouse. I found it really confusing, and what I think is also not really doable is in the presentation it detected the intent of the user to lie a graph upon another one, and the machine just did it pre-assuming that the user would want to do it. I found that also. Yeah.
You mean in the conference setting at the end? Yeah, I believe, if I understand the video right, that some of the content is being driven by other members of the other participants of the meeting, putting stuff in place there in order to sort of make that case. I think that's what was going on there. Yeah, but yeah, there's quite a mix of interaction techniques for sure, and some of the gesture control is a little bit unclear maybe what's going on there, but for sure it's assumed that you can do it this way. Yeah, go ahead.
And there was the screen that was like that covered the whole desk.
Mm-hmm.
That's also something that we see today, and it was even able to directly scan a document.
Mm-hmm. Mm-hmm.
And like also in a way that it is readable.
Mm-hmm.
You know what I mean?
Mm-hmm.
Because normally to scan something you have to be completely dark.
Mm-hmm.
Yeah, and also it was able to do these automatic screenshots when it was evaluating the output of this man.
Mm-hmm. Mm-hmm.
So yeah, in some sense it recognized two different human loss and when he was facing front and when
Right.
he was facing back.
Right. Right. So these two things. One is that everybody notices, of course, this weird, like, sort of curved surface that she's interacting with most of the time. Right. Her workspace is not just a desktop screen that we're used to today. It's not just a surface on the table in front of her where you might say, yeah, today I can do stuff on like maybe a tablet or something, but they were actually joined into a single continuous surface, right, complete with the curve in the middle, and being able to move stuff back and forth freely. Yeah, and the scanning, of course, is something everybody finds quite amusing when she just rubs this thing and it recognizes. Not a technical impossibility from today's point of view, but an interesting idea for an interaction metaphor that is sort of trying to borrow from what we know about the real world, right? Like rubbing in order to copy a picture or something. So in general, I mean, this is an HCI class, right? So yes, it makes sense to pay attention to like what are the technical like software and underlying software challenges there. That's interesting, but what I'm most interested in is what are the interaction techniques that are being suggested, and how did those make it into today's world? So you're right. I'm having a hard time rubbing newspapers on my iPad today. It doesn't work. And yes, so the sandwich was being scanned in as well, right? So when she put down her sandwich, that got scanned too. And did you notice what happened? Yeah, she wiped it away, right? So that's interesting. Think about it. You have to, as a director, basically, you have to say, okay, I want a failure to be in my video, right? I want the sandwich to get scanned in, which is not what the user wanted, and then I'll show an interaction technique that is somewhat believable in order to recover from that error state, right? That's an important message here that the Sun video does. This is not something we're seeing as much, for example, in the Knowledge Navigator. Yeah, there are smaller things where there's maybe a sort of a bit of a misunderstanding, but in general things go quite smoothly there in that setting. And anything else that struck you? Yeah, go ahead. Oh, yeah, that gets misunderstood a lot. The idea there was when somebody says, bless you, did you take your medicine, and so on. That's actually already her husband talking over the video conferencing line. So apparently he was able to connect in without her accepting that call and sort of faking of course, the Hal from 2001: Space Odyssey, the sci-fi classic. Like, sorry, Dave, I can't do that. That was all a bit of a cultural joke there. But yeah, the video conference was an interesting setting in general, right, with the signatures happening via conferencing and stuff like this. Yeah.
Yeah, I want to say something maybe not as interesting, but like on the new iOS, you can basically scan like kind of what she does with the man, like push the figure of a person, and iPhone will automatically cut it.
Oh
off
yeah.
The picture
Yeah,
and
yeah.
insert it
Yeah, yeah.
somewhere else. not like in the video, like make someone dressed like that, but
Mhm.
you can already do this, and it's like a new feature.
Yeah, the lifting off of an object from an image, right?
There was another thing which, like, I mean, it's a typical whatever, like you mistake, like it says their voice command is not recognized, but I don't remember what she says.
Yeah.
But this is quite normal, but they also put it there.
Yeah, that's right. Yeah, so about the lifting off, I mean, we don't have a full like 3D reconstruction of a freely movable avatar from a couple shots of video yet, at least not in our everyday desktop applications, but we're slowly getting there, you're right. And the voice command recognized that was when she was sort of preparing for rehearsing her presentation, right, saying things, and apparently the computer was continuously listening in, seeing if there was a command meant for the computer, so it couldn't make sense of what she was saying, it's a good example, another example of an error situation popping up and showing how the system copes with it and how the user is informed about the mistake and seeing how they can recover. Anything else? Leonard.
We had the interaction with the tablet, where the PC was also in the tablet, and the tablet also controlled the robot arm with the camera.
Right.
To make similar movements as the tablet in the room to have full control over the complete movement and the shots of the video itself.
Yes, so that was a great example, almost you could say of like sort of a telepresence example of telerobotics, where she's in Detroit in her office, right? Of course they're building a car, so they're in Detroit in this video, and AJ is in San Francisco, and she's controlling his car sort of across half of the continent in order to make that shot. Yeah, that's a good example. Did you have another one? Yeah.
No, but it could also today nearly be like, it looked like she would use AR to augmented reality.
Yeah. So that it could be an AR enabled view to help her actually do the right movements, and that's an interesting point. It brings me to, you may have noticed, we're seeing the actors interacting with the screen a lot, looking at their faces. Why do you think we're not seeing an over-the-shoulder view of the UI as much? Yeah.
Because it seemed like they didn't really have an idea how they could fill all this large monitor space. Most of the time, when you could see the monitor, it was like 80% blue desktop, blue background.
Yeah.
And the interesting parts were like very small widgets or small windows, and most of them were only used for a few seconds, and after then they remained on the screen but were completely useless for the current task.
Yeah.
So they had, and I didn't really see what they used the curved desktop or horizontal monitor for. They used it for scanning, but why would they need a monitor there? Because as soon as she scanned the paper, she moved it onto the front monitor, because it's not really comfortable to look at. So
down here.
I know what they intended with the horizontal monitor.
Yeah. So those are two interesting points. I think first of all, the image is mostly empty. That's right. I think when you read what Tognazini says about this, making this production video, the idea was to have a workspace similar to your desk, sort of, which doesn't necessarily need to be full everywhere, and it's fine if you're just placing documents wherever you need them. You got to think at this point, people were like looking at desktop screens that were maybe this size, if they were lucky, maybe a 17-inch screen or something like that, and so everything was very much crammed into very little space. So this was kind of like an anti-model of how you interact with, if you have tons of display space and you don't need to cram everything on there. The reason why we're seeing a lot of shots of people's faces interacting with the screen is that that's much easier and cheaper to produce as a video prototype than if you actually have to fake the interaction on the screen as a person is touching. So we're often seeing things as the person is interacting, and then we're seeing the result on the screen, but we're not seeing the live movement because that's really, really hard to do, because remember, this was a video prototype, right? This was not built, right? The system didn't actually exist. About the desk, I'll come back to that actually later when we talk about the curved display in a minute. But the joint surface of the vertical and horizontal is one of the key ideas that they were trying to push, to say, like, I don't just have a screen here, but I can also use the surface in front of me if I want to display and document, move it up there if I want to look at it. You're absolutely right. If you want to look at something and read it, it makes more sense to have it here maybe. But if you want to write on it, for example, then it makes more sense to have it in front of you. So that's kind of the idea of the joint surface there. But yeah, this is definitely something we're not seeing everywhere in everybody's office. So somehow that didn't quite catch on, right, at the time. Anything else from the video that you guys noticed as sort of unusual? Yeah.
When the second guy called, in video call, nothing interrupted, and she did a movement, they could see each other.
Yeah. Although I think that's become sort of almost like a standard move, right, in multi-person video conferencing, like putting people kind of like sideways like this. The tilt. Yeah, the tilt. That was continued actually when you look at the conference room scenario, where 3 people were actually virtually there, right? They were joining by video conference, the managers at the end of the table, end of the room, and they were being basically rendered as, I don't know, holograms or something that seemed very natural to be in the room. And that's something we're still struggling with today quite a lot, right? People still end up being in a conference and they're like on a giant screen, way too big, or on a little small screen, and they don't actually look at people. I know we had a PhD defense just the other day, and I was really freaked out because one reviewer was joining us from the where was he based? Waterloo. So he was in via Zoom, and at one point he somebody else started talking, and he literally on the screen looked at that other person, which was pure chance, right? Because that other person happened to be at that location on his screen, so that's where he looked, so the camera saw his eye movement. But it really felt as if he was looking at the person in the room, and I was like, well, that's weird, although that's the most natural thing that should usually happen. So we're still far away from eye contact working in these remote presence scenarios. All right, so lots of stuff with the video that was new, but you could tell it wasn't quite as far out maybe as the knowledge navigator from like what it was assuming would be possible, because the idea was to have this sort of 10-year time frame. And it's kind of interesting. I'd never noticed this, but this year I noticed that everybody's talking about very sustainable solutions there. There's like somebody looking at rainforests and deforestation and the Sahara, and then the next person's talking about hydrogen-driven fuel cell cars, and plus part of the building was happening in Ukraine, so very weird coincidence of things here. So the video, when it was made, also taught the group that was creating this video prototype a lot of things, because there wasn't much in terms of examples of how to make these like grand vision videos at the point, and certainly not documented and how to do it. So they learned a couple things from this. The first one was that when you make a video like this, you have to continually question yourself if your assumptions are realistic within the 10-year time frame, because it's so tempting, of course, when you make a video prototype to just go crazy, right? Because you could make this thing do anything. It's just a video, right? You fake it, you tape it, and you're done, right? It doesn't actually have to work. So keeping yourself constrained to saying like, yeah, that's realistic and that's not realistic, was apparently a big thing that they learned during the process here. The second thing they took away from this was that you need to iterate video prototypes like any other prototype. Now, third part of this class, which is going to start after these history lessons over, is all going about iterating over prototypes, right? We're going to talk about the iterative design approach to creating user-centered software and user interfaces. And what they're basically saying is a video prototype should work in the same way. It should also be iterated over, so you don't just design it once and then make it, but you actually make a first version or cut a rough first version, and then you think about is it the right prototype? How do we need to change it? Adapt the idea of how our system works, and then make a new video. Yeah, including things that go wrong in the story, like, the lady has a cold. I mean, how cool is that, right? You have to come up with something like that that is a simple, minor nuisance, but it will lead to a much more believable story, and it will also help you as a design team to reflect on, okay, so if people are not the perfect user that has no problems, whatever, what's going to happen, right? So it also sort of grounds you as a design team. Avoiding impossible designs in hardware was another thing that is closely linked to this thing up there, right? The 10-year time frame, to keep that in mind. It's very tempting to come up with interaction techniques where you say, like, oh yeah, it'll just do this, right? But if it is impossible, if you can't imagine, in this case, with a 10-year time frame that would get built, then you shouldn't do it. And they then found that they needed to design the interface first and then decide which film scenes to make with this based on the budget, right? And this is why, for example, you see that using a mouse, for example, using voice commands, using the reverse angle, looking at the user in front of the screen and seeing their face was much cheaper to produce than actually using gestures or pen input, for example. And that's why some of the scenes were angling more towards one interaction than the other. All right, so for Starfire, the team around TOG actually wrote a paper on this video prototype. It's not a long paper at all, but we would really like you to read this one. It's called the Starfire Video Prototype, a case history, the video prototype project, a case history, and it's in Chi 94. So once they were done with the video, they published this paper about their experience and how they made it. So this will give you an idea of the video prototyping guidelines that evolved from doing this project. And they are actually going to be quite useful to you, because guess what you're going to be doing at the end of the semester? A little video prototype, right? So you're going to be prototyping a software, but in the end we don't want a working functional system from you. We want a video that shows how the system would feel to be used. Kind of similar to what we saw here. I mean, yeah, I don't expect a 15-minute, polished video with professional actors. That's okay. But the idea is, to use a similar approach. Right? These videos, you can find this on the online digital library and also at this website from Tognazini. And once you're there, while you're there, check out his website. It's an interesting resource. There's also a book that Bruce Tognazini wrote that's called Tog on Software Design. He first worked on interface design, and then he wrote on software design. That actually has more information about the Starfire prototype. He actually planned to call the whole book Starfire at first. I've always found this interface sort of fascinating, especially this weird idea with this joint screen. And some of our PhD students really got into this topic of how do you interact with a touch screen in various ways. And at some point around the early 2000s, multi-touch technology became really available for labs. And so we were able to actually take this idea from Bruce from the 90s and build it. So here, this is Christian Corson, one of our PhD students a couple of years ago. He is at our own, what we call bent desk, which is literally like the Starfire setup, with the joined horizontal and vertical screen. And many of the problems that you mentioned and the questions that came up were things that we then addressed in our research around this, right? So what do you do with this surface down here when you have both of these joined together? We found that, yeah, writing is actually quite nice on the horizontal. Looking at stuff is more comfortable on the vertical. So people would be moving documents from the vertical to the horizontal based on what they were trying to do with them. We also found interesting mismatches between how people, when people try to flick something from up down here, like a virtual document down here, flick it up to the screen, they would actually always misjudge the direction, which is based on some perceptual problem people have with these curved surfaces. It's a very unusual, unnatural interaction. So those are the things I find interesting, right? I'm learning something about how people's brains work ultimately when using this new technology, and then we can think about how can we fix these mistakes people make by making and thus make the technology more usable and more useful for people. What I thought was really cool when we opened up the HCI Center in 2011, I think it was, we actually had Bruce Tognazzini over here. He came over and he took a look at this thing at the bench desk, and he crawled around all over this thing, and he was super fascinated to see his own sort of video prototype vision that never worked, right, as an actual working product here. So that was a little fun event that we had there. Okay, so that's Starfire. It's a bit of a longish story, so to say. We're going to take a look at two other directions now that we're not going to do with videos, just to point out that, of course, they existed. They had an impact on HCI. And the first one is virtual reality. Now, I'm not going to give you a teardown of virtual reality today. For that, you should go and see Torsten Kuhlen's excellent classes on VR. But I, again, want to just point out this incredibly long delay between the first ideas popping up in the research community and the thing actually finding a foothold. So here's a guy in 1968 who actually builds what he called the head-mounted display. Right? This thing was, you could put up, and two tiny little CRTs would actually show you pictures on each eye, and it would do head tracking with a monstrous setup that would let you basically use a head-mounted display. Right? And that's, anybody know this guy? The name ring a bell? Yeah?
Yeah, he also had this fun little, I don't know, Streichholz scene for the first person to use this device, because those CRT monitors actually run on a very high voltage as opposed to our screens nowadays. And therefore this device was not really that harmless, so they had to like choose a poor guy that had to first try this.
Yeah, I could imagine that. Yeah, I saw some of the setups of it. It looked pretty brutal too. And that's Ivan Sutherland, Sketchpad. Right? It's the same guy who did his PhD thesis on Sketchpad, and a couple of years later created the first virtual reality system. He said he saw it at I think some airplane manufacturer who had mounted cameras beneath the like infrared cameras beneath the plane, and they gave this picture to the pilot in order to see at night where they were landing. Right? So they were basically like forwarding it. And he said, well, instead of using a camera picture, we can just use a computer to generate that picture on the person's eye vision, stereoscopic vision. And by that, we can put them anywhere, right? So they had a very simple sort of, you could move around inside a wireframe environment, basically. That was pretty much it. But quite mind-blowing if you think about that was possible back in 1968. And of course, the key advance here is that you are now being placed into a three-dimensional world of computer-generated things and having this illusionary environment. Next up, I want to briefly, again, for this we have a whole class, right? My esteemed colleague Ulrich Schröder teaches web technologies and knows much more about this than I do. But just to point out again how far this goes back, Tim Berners-Lee at CERN, a Swiss research institute, in 1989 came up with this idea of, hey, we've got FTP and we've got Telnet and we've got these weird sort of text-based ways to download things, even graphics and stuff. It's kind of cumbersome. What if we had a graphical browser where I could, see text and images and all these kinds of things, even if they're on remote servers, and it all just gets joined together, and I can jump from one to the next by clicking on stuff that I will call links, And so that's how the World Wide Web came around. And this is actually a screenshot of his one of his earlier attempts, not the very first one, but shortly after that. Here you can see basically the grandfather of Safari and Internet Explorer and so on, the hypermedia browser editor. And here's another window open that has hypertext, that has HTML basically inside it, right? Here's another one. Welcome to Hotwired, right, which was a news collection. And interestingly, if you end up taking DIS2, we'll come back to this. This is all running on a Next computer. Look at this. Right? So this is on a Next. The Next being a company that Steve Jobs founded after he left Apple in the early 90s, and that created the predecessor of Mac OS X, which is now running on every Mac that is being sold, and also with this the basis of iOS ultimately. Anyway, so this is the key advance here is of course this new way of accessing remote media and content. Ubiquitous computing. This is a term that was coined by Mark Weiser, who worked at Xerox PARC at the time. He joined PARC in 1987 and became sort of the head of computer science lab there very, very quickly after that. And a year after joining them, he actually coined the term ubiquitous computing in 1988. So he's widely considered the father of Ubicomp. He unfortunately passed away in 1999. But I want to share the idea of ubiquitous computing. And one of the articles that I think lays it out most clearly and that was extremely well received, and it's probably one of the most widely cited articles in HCIF, is the article he wrote in 1991 that was called The Computer for the 21st Century. And in this he makes a couple of really insightful observations. The first one is that if you ask yourself, if a new technology enters, we've talked about hobbyist and professional and consumer adoption of and the Baroque phase of technology. But if you look even longer, if you think about what happens to technology in the long term when it gets really, really adopted by society, what happens to it? And he says it disappears. Not in the sense that it's not there anymore, that you're not using it anymore, but actually more in the sense that you're using it without noticing it. It becomes, as he calls it, a fabric. It joins the fabric of everyday life. And maybe the best way to understand how that works is to take an example, writing. If you take writing, if you were an early scribe, around the time that writing was being invented, you had to know how to, make ink, right, in order to write. Or maybe you had to know how to bake clay tablets in order to be able to write. So there was an enormous amount, not just of knowledge about the letters and how to express yourself, but also about the underlying mechanics that really, I think when you're writing, that's not what you're interested in, right? You want to just write. You don't want to deal with, oh, how long do I need to bake my clay tablet? And oh God, my clay has gone dry, right? And so if you look back today, writing is everywhere, right? Try to imagine a world just for a second without writing, right? What would go away? I mean, we print stuff on candy wrappers, right? It's so ubiquitous that just writing is literally everywhere. And another example would be motors. If you look at how motors got invented, like with the steam engine and early electric motors and these kinds of things, there was oftentimes when you had a factory, you would have a whole factory floor that was all running off a single motor, because a motor was super complicated and needed lots of maintenance, and it was super expensive. So you had one motor, and then you had belts literally going to every workstation, where people were building stuff, and they could use some of the motor's power by having this little belt that transferred some, I don't know, rotating power to their workstation to, I don't know, drill something or something like that. And if you think about what motors are today you have tons of motors in your car, right? I mean, probably by now this number is even higher of like you probably have more like 100 motors in your car. Every single thing that happens by servo control, right? Your I don't know, your mirror, moving in and out by itself. That's a motor. Right? Your windshield going, or your window going up and down. That's a motor. And you don't even think of them as motors anymore, right? They're just there, and they do something automatically or because you pressed a button, and that's that. So you could say both writing and more recently the motor have sort of disappeared into the fabric of our everyday life. And now think about, computing, right? So take your I don't know, take your laptop, for example, right? Or maybe to make this even more drastic, imagine yourself with a PC around the time that Weiser was writing. This was like the mid-90s, right? You are basically like a scribe with, a pot of clay that's going dry, right? So you're like, oh, I want to write a letter. Oh, but first I have to update my Windows installation, and oh, now I have to, do this, and I have to do this technical thing, and you're jumping through lots of technical hoops of stuff that shouldn't actually be necessary in order to do the job that you want to do, right? So the computer is more at this early scribe stage rather than having really, disappeared into the fabric of our everyday lives. This was the observation that Weiser made at the beginning of the 90s, that he really considered IT, to be far away from this idea of disappearing into everyday lives. And so there are a couple of reasons why this vision of Weiser's of ubiquitous computing is actually one of the most, I would probably say, convincing visions of how computing sort of needs to evolve, because it matches, human psychology very much. If you consider what you do with a hammer when you're hammering a nail into the wall, you're not focusing on the hammer, right? Maybe you're focusing on that board you're nailing to the wall, but maybe you're actually thinking already about, like, oh, how you're going to complete that whole building that you're constructing one board at a time. And that works so that the hammer sort of, disappears from your conscious thought. It's just a tool that you use that works so well and so reliably that you don't need to think about it. Until the head of that hammer becomes just a little loose. When that happens, when it shakes just a little, then all of a sudden you're like, ooh, you're going to get very careful using it to hammer that nail in, because all of a sudden the tool, the hammer, has come back to the front of your thought, and you are focusing on the hammer because it might break, it's not reliable, you need to pay special attention to it to do its thing, and you're distracted from the thing that you're actually trying to do because the tool gets in the way. And so this idea of ubiquitous computing is basically just saying we need to make IT more like a hammer so that it literally disappears from our conscious thought. We don't want to think about it anymore. We just want to use it without having to worry about it. And a lot of the trends that were happening at the time were very much the opposite. For example, he found that PCs at that time, the idea of a personal computer, he found misplaced. He thought that's just a transitional phase. We really want, and that was actually quite true if you look back today, we want people to have tons of IT, PC-like devices of all shapes and sizes that all run some OS and that have some user interface and have some data and they all talk to each other, rather than having everything on your personal computer. That seemed weird to him. It seemed to him a little bit like that one motor, on that shop floor that drives all the different workstations with belts. And multimedia, which was, as we saw with the video from the Knowledge Navigator, multimedia was becoming big. And he said, well, multimedia is great, but that's grabbing even more attention and pulling more attention onto the tool rather than letting people really enjoy, everyday life and having IT just quietly support their tasks. So there was a lot about that vision that seems to me to just make a lot of sense. Ubiquitous computing is also known as Ubicomp for short. You will find that term a lot. It's also known as the idea of the disappearing computer. Sometimes it's also called calm computing, calm in the sense that it's not, distracting and stressful, but it's really, really something you can use without having to worry about it. And the last term that also matches ubiquitous computing quite well is one that you probably know. Does anybody have an idea what current trend matches this idea of ubiquitous computing quite nicely? Yeah?
Maybe the trend of augmented reality to incorporate digital information to our everyday life without it being obstructive or without using any complicated tools to make it.
Yeah, exactly. So AR, augmented reality, is sort of another term that is very closely related to what we're doing here with Ubicomp. Okay, so the idea is basically to, instead of building more and more powerful computers that are the focus of your work, rather than that, putting smartness into everything around you, into your furniture and your walls and your windows and whatnot, and making the world around you sort of activating it, as Weiser put it. So this paper, the Ubicomp paper, the computer of the 21st century, introduces a couple scenarios. Again, a technique that you will also get to see when we talk about designing user interfaces. He describes a very normal sort of day in the life of a family, and he has some visions that he gives us as examples of how he could imagine Ubicomp to work in the future. This wasn't realistic at the point, but the idea was to see where the road could be headed. The first example he gave was, you're standing in your kitchen in the morning, you're making yourself breakfast. You look out the window, and normally when it's snowing or something, you see the tracks of your neighbors that maybe already left their house or something. He says, well, we could do that with ubiquitous computing, have virtual tracks if the neighbors have left their house or not, because that would give me a very sort of ambient sense of, yeah, the neighbors are there, they're all right, they're doing their daily things, everything is fine. And of course, immediately also bringing up the challenge of, yeah, that would be a cozy feeling if it's a neighborhood where everybody knows themselves, but it could also be freaky, because if you don't know your neighbors and you're seeing when they left their house, then you probably wouldn't want to see that information because it's privacy invading. Another example he gives then is, you read your news, and in his vision, you would still be reading that on a piece of paper because it had, to his mind, has all these nice affordances of something you can, hold on the sofa and crumple up and put in your pocket, and but with an electronic pen that would then be used to scan in things, similarly to what we saw with the bent desk. The next scenario that he describes is quite telling because it's something that will come back to us when we talk about the devices that the Ubicomp team built. He says, then you've got, your garage door opener isn't working. So you need to fix it, right? You need to change the battery. But for that, you need the manual because it's complicated. So where is that manual? And he says, well, rather than having to hunt down that manual, the manual knows where it is. In his world, the manual, even though it's a little bit of a paper booklet or something, is actually tagged with a little device. Today we would probably call it an AirTag, and so it knows where it is, and it's easy to find that lost manual by using the attached little badge that knows that makes this thing aware of its own location. The story then that goes on that Weiser tells in his paper of driving to work. So you can see this is all very American, right? So you've got your own house and next door neighbors and stuff with their own house, and then you drive to work in their car. But bear with that for a moment. So he says, well, you got your rear view mirror, but in the Ubicomp world, you also have a 4-view mirror, which means this is a mirror that looks forward, and that, for example, points out things like traffic jams, empty parking spots, or particular shops. You can think for yourself, did that actually happen? Does that exist today? And if it does exist, what shape has it taken today? At work, then, there is, again, the idea, how do we get everybody to talk more to each other? Well, we're not going to create a chat application that everybody uses at their laptop because that would suck. No, instead, we take the coffee machine that already exists and we instrument it so that it sends a ping to everybody when the coffee is ready. So even people who can't smell that coffee is ready can be aware of it, and then they can mingle and join and talk to each other around the coffee machine like they used to. So you see the fine difference here, right? Rather than putting stuff onto a computer and pulling people more and more into a virtual world that's away from their normal environment, you help them, be more productive, enjoy more of their natural environment that they like to be in. And then when you see what he envisions for the actual work setting, and this will lead most closely to the devices that we'll see in a second, he imagines the workplace to have not just a personal computer for everybody, but actually, and this is maybe the weirdest thing, computing technology being so cheap that it's like a paper pad that you just pick up when you need it and you put it away when you're done with it. It's not even yours, right? So you would enter this room and there would be paper pads lying around on every place, and but they would actually be like tablets, and you would use them to do whatever you need to do here, and you would leave them behind because you don't care. They're so cheap, you don't need to take them with you. Everybody's like, oh, I would steal one, I would steal one. But that's the wrong idea, right? The idea is if IT really disappears into the everyday world, then it would just be there for us to use as infrastructure. And apart from these tablets that they imagine, there are also smaller devices like the ones that you attach to your garage door manual, and larger devices like whiteboards, like what we have here, maybe with a screen, but a little bit more interactive. So the idea is that you can really move really effortlessly between different machines, that your content actually isn't living on your personal computer, but it lives, well, today we would say in the cloud, right? And that you move between these devices effortlessly. And we will see at the end of this video, we'll see a little example of a meeting that uses these devices. First, we'll go through the different devices, and then we'll see the meeting scenario being played out. And again, those are researchers acting in this video, so sorry for the less than professional acting maybe sometimes. They also kind of make the mistake that the meeting is actually about the project. And we'll drill that into your heads that you're not going to make a demo of your project that is about your project. Use some other domain, right? But anyway, I'll roll the video and let you judge for yourself how you like it.
Ubiquitous computing. Coined by the Xerox Palo Alto Research Center's Computer Science Laboratory, this term describes a vision of the future. Just as electric motors have disappeared into the background of everyday life, Park scientists envision a future where mobile computational devices will be similarly transparent. Potentially numbering in the hundreds per person, these devices are nothing like you use today. They are mobile, they know their location, and they communicate with their environment. They can be active or reactive, changing their computation based on their current location, their environment, and external events such as timers, alarms, and sensors. The seeds of ubiquitous computing, also known as Ubicomp, have been planted by Park's Computer Science Laboratory and are composed of 3 classes of devices. Yard-sized devices span 18 inches to 6 feet. Foot-sized devices range from 6 to 18 inches. And finally, inch-sized devices are 6 inches and smaller, and can be embedded in furniture, light switches, and other objects. The Park Tab belongs to the inch-size class of Ubicomp devices, and is the smallest built at Xerox PARC. It is a pen-based graphics terminal that uses an infrared network for its communication. The Tab design emphasizes communication over local processing power for 2 important reasons. First, wireless communication is critical for mobile computing. It allows users to seamlessly connect to the information infrastructure being built from existing wide-area networks. Second, and more important, it is the physical size of the device. The computer science lab's premise was that the Tab had to be small enough to enable researchers to carry it throughout the day. However, this requirement placed severe constraints on both the amount of local computation as well as the battery life that could be built into the device. As opposed to designs used for other personal digital assistants, CSL took a novel approach to integrating the Tab's communications and size requirements. The result is a PDA that runs a simple operating system and functions more as a terminal than as a workstation, with its applications running on remote hosts. The tab shell provides a graphical user interface for starting and controlling tab applications. Tapping an active area on the screen, either an icon or text field, initiates a shell action such as starting an application or moving to a new screen. Once an application has been started, it takes control of the tab. Any pen or button events from the tab are sent to the active application via the agent. Only one application can write to the tab's display at any given time. The middle button signals an application to suspend itself so that control returns to the tab shell. The weather application provides an up-to-date weather report for the area near Park. It reads the temperature and wind speed from Park's rooftop weather station and retrieves a timely National Weather Bureau forecast from an internet service. The stylus interface allows the user to scroll through the text of the forecast. The dictionary application demonstrates access to a database that does not fit on the tab itself. By tapping on the keys of a graphical keyboard, the user moves through a word list in a manner similar to Emacs's incremental search function. Tapping on a word in the word list retrieves its definition from a network-accessible dictionary. The calendar application allows access to the user's online calendar. The top button reviews appointments for a given date. The bottom button adds a new appointment for the given date and time. Again, text is entered by tapping on the graphical keyboard. Hand printing recognition is an alternative method for entering text. CSL is experimenting with a radically new script called Unistrokes, where each character is represented by a single stroke, which is faster to write and easier to recognize than a conventional character. Unistrokes enables a style of text entry where characters are written one on top of the other. This technique allows the Park tab to compete with larger devices where each character is normally written sequentially. The tab incorporates a Unistrokes trainer application, providing the user with an easy way to learn the Unistrokes script. The strokes are grouped into classes based on the degree of difficulty in remembering the stroke. Each class is tested separately. The user is presented with a letter and responds with the appropriate stroke. Should the user make a mistake, a correct sample stroke is drawn. Future applications are planned that will allow multiple tabs to collaborate simultaneously using groupware currently under development. The MPad is one of the foot-sized devices in the Ubicomp environment. The purpose of the MPad project was to build a device which could create the illusion of having a portable wireless tablet computer containing all the computational power of a workstation. For this illusion to become reality, CSL chose to separate the computational engine from the portable display device. For mobile computers and shared drawing tools, the last decade has been one of evolutionary growth. But ubiquitous computing in the MPad brings them together, for the first time enabling a revolutionary change in work practice.
Here's what I've drawn for the animated section. It's an MPad, a base station, and a workstation. See anything you want to add to that?
Well, we could add a second pad to show that there isn't a one-to-one correspondence between pads and base stations. I know. We could put it on a tether.
Yeah, I think that might work.
What are you guys working on?
It's the animation section of the MPad video. Can you think of anything we might need to add to what we've got here?
Well, definitely. Seamless, uninterrupted communication is an important issue.
How's it going?
Oh, hi, Ron. Well, we've added an MPad tethered to the first base station, and we've added a second base station to animate roving. You see anything you might want to add?
Well, that looks pretty good, actually. But I know Bob had a few ideas. He's still busy hacking away for the demo, but we should be able to reach him. Bob, this is Ron. Are you around?
Hi, Ron. What's up?
Hey, we're working on the MPad animation right now. It's all up on WB. Is there anything else you wanted to add to it?
Let me see. Let me take a look.
How about adding a second pad out here, maybe at a remote location, and it could show off the
audio features of the pad.
Okay, nice. That emphasizes that the pads don't have to be co-located for sharing.
Thanks a lot, Bob.
Okay, I got to run now, but I'll keep WB on and monitor your progress.
Sounds good. Talk to you later.
Okay, looks like we've got it. I'd like to keep this WB session around so that we can come back to it later. But right now, I think I'd like to move away from the animation segment and work on the meeting segment for a while. It'd be nice if we could
Park's ubiquitous computing vision includes several devices. The LiveBoard, MPad, ParkTab, and Active Badges are key components in this wireless revolution. This vision brings you more than remote collaboration and shared drawing. You have the power of your workstation and a tablet computer. You have unlimited freedom to change your location as the wireless communication infrastructure connects you from one base station to another. Physical boundaries disappear as your computational boundaries and power expand. Pieces of the ubiquitous computing puzzle are coming together at universities and research centers worldwide. At Park's Computer Science Laboratory, the ubiquitous computing revolution has begun.
All right, so let's talk about what we have here. So what was in the video that you thought, yeah, we've kind of solved that issue, or that's become standard practice today? Or what is there that is completely different today? Actually, yeah, Leonard, go ahead.
So I would say something that we have today is the connection between the different size devices and different kind of devices, like or a mobile phone or a tablet or a notebook and the standing desk, the standing PC and somewhere, or server somewhere where we can interact with, or some smart display or something. We today can already move things from one to another and collaborate on that.
Yeah. So today that's become possible. Maybe not quite as fluent as one would possibly want, right? So if it really was as fluent, then anybody here could, like whip out their smartphone and just say, hey, let me send you a file over, and it would pop up open here on my screen. And it's not that integrated yet into the systems. So we're on that way, yeah, but it's more happening from a different point of origin than what Ubicomp is envisioning, where Ubicomp is envisioning this. You start out with the idea of the infrastructure, and you put devices in there that all the time are connected to this infrastructure and share the data from the beginning. Whereas today we have more of the sense of, yeah, we have a device, and the device has its own sort of ecosystem, and then we try to bridge into other devices, right? We try to bridge to the cloud. But you put something, I don't know, into the wrong folder on your Mac, and then all of a sudden it's not in your iCloud, and then you're on your iPad, and I can't see that one because I put it into the wrong folder. So it still is a little bit of a patchwork solution. Anything else you noticed on the video? Like, what about those large boards? Are those? Are we doing this just like that today? Any current tools? Like, what would that be today? Yeah. Yeah. Yeah, we have smart boards, so we can collaborate locally on a board and sketch on them, and it's being recognized by the computer. You can even run a Miro session on it and have remote people join, right? So that's an example where this like graphical sketching, diagramming kind of collaboration has kind of become pretty normal for us, right? Okay, let's look at the devices real quick here, because I think it's important to understand what these devices are doing. So you got to these devices have to know where they are. This is one of the assumptions that Park makes with the Ubicomp vision, because they consider the fact that a device knows where it is so crucial to how we humans like to think about these things, that we just need to have that, right? Even indoors. And I don't know about you, but my devices, yeah, they track pretty well outdoors, but once you move to an indoor environment, it actually becomes kind of tricky, right? To know exactly, well, is this thing in the bathroom or in the living room or in the bedroom? The assumption, though, is that if a device knows exactly what room it is in, maybe even what part of the table it's at or something, it can do a lot of things to adapt significantly without any weird artificial intelligence being thrown on top of it, just by knowing that all your phones could have easily turned off the moment you entered this lecture hall so that you don't get calls, right? It's a no-brainer, really, if the devices would know that they're in this room. We're not quite there yet, actually. It's getting there slowly, but especially indoor location, is actually turned out to be much more difficult than people thought. The three device classes, tabs, pads, and boards, are interesting to distinguish because they're like at the inch, foot, and yard scale, and there's hundreds of them possibly per person versus dozens versus 1 or 2 per room on these different scales. So let's take a look at the Park tab first. There were about 50 deployed in Park and also in the European outlet in 93. And the idea was that you would basically take one of these and attach, a smaller version of them, of course, to the spine of every book that you have, right? So that your books could no longer be misplaced. You could think about these things as almost like a post-it note that's activated, or something that can basically, make non-animated objects, as they call it. Today you'd call it probably smart, right? So you can make non-smart objects smart by attaching them to objects that you might want to, for example, find again. But you could also use one of these with its simple buttons on here as a voting tool or a consensus tool in meetings. And the idea is that you could also use it as an active badge. So you could have one of those with you, wear it, and make it identify you as the wearer. But they could also be used as things that just lie around in the environment, like post-it notes that anybody uses when they need them. Plus, if you're in a meeting and you want some information, let's say you're looking at this slide right now and you're like, oh, I want this slide, you would take your badge and you would just pull that slide onto your badge and have it with you, right? So you might say, well, that sounds a lot like maybe a smartphone, but it's not quite there yet, right? Because I mean, the constant connectivity that's being assumed by the research project, right? That was a wonderful example of how you set up research, right? So you say, let's assume constant connectivity, done, right? And then they built some prototypes and they made it work with IR connections and early Wi-Fi, etc. But of course, even today, we don't actually have constant connectivity, right? It's often enough you're like, oh my God, I don't have any internet. So the assumption is easy to make, and it's interesting and intriguing to think what that means, what that could mean for the ecosystem, even though it's not maybe entirely practical. The biggest difference, of course, is if you think about tabs and you say it's today's smartphone. Well, your smartphone is a very personal device. You're not going to give me your smartphone because I need to make a note and then I keep it, right? That's not how it works. Your smartphone basically has so much of its data attached to it, and also the value of it, that you're not going to freely pass that around. But imagine if it was just something that cost cents instead of hundreds of euros, and if the data was fully attached to you and not that particular device. So if you give it to somebody else, not a problem, right? Then it's theirs for the moment, and their data cloud sort of maps itself onto the device. That's the difference between the Ubicomp vision and what we have today. If we look at the Park Pad at the second example, it's a crossover with a laptop and with a pad of paper, basically. Could say today maybe the form factor and the input techniques, etc., and the connectivity is much like an iPad or a tablet. But again, the assumption was it's a scrap computer, so not personal. You walk into a meeting room, these things are lying around, right, for you to pick up and use, put your data on, link to your data, and then when you leave them again, your data moves off them again. So it's, in a way, this is a picture that shows a great example. It shows like 3 of these things lying around. And even today, you don't probably own 3 tablets, right? So the idea was to say, why are we trying to cram everything that somebody's interested in onto a single screen, right? Again, similar to what we saw with the event desk, where they said, just imagine a really, really big screen, right? Your entire workspace is a screen. Or you've got lots of screens. And if you want to look at 3 papers side by side for your research, well, you take out 3 tablets and look at them side by side, not a biggie, right? That's the assumption here. That is quite different from what we do today. So again, if we compare this to modern things like the iPad, you can tell that the key thing that's different is this personalization. That is currently the case. These are personal devices, and all this like passing information back and forth is sort of added onto it. We have the board as the last format, used as like a video screen, a bulletin board. In fact, when you walk by one of these things, It would detect that you are walking by. It would display information that you might be interested in. For example, if you're biking, then it would tell you, hey, it's going to rain if you're on your way outside. If you're by car, maybe you don't care about that. It is a whiteboard, as we saw, in like this, used like a Miro board, but also as a flip chart. And it's very clear that you need a different UI, right? This is something that the guys who designed the iPad, for example, didn't quite get, right? This like tiny Windows Mobile version, these early ones, Windows C or whatever it was called, was still a desktop environment, just on a small screen, and that doesn't work. So here it's the same. You know, we've actually, when I was working at Stanford, we ran early like desktop systems on these boards that we had similar boards mounted in our interactive meeting room, and we could literally see smaller people jumping up to reach the close button for a window, right? And that kind of makes it very, very obvious that the interface needs to change if you change the size of a device like that. So keyboard use is awkward in front of these things. The menu bar is hard to reach, and also the way that these parkboards were being used, they were shared even across the Atlantic. So let me maybe just wrap that up very quickly. If you compare Ubicomp to the PC or virtual reality, then it's clear that Ubicomp has a different direction, right? It's this calm computing that moves technology into the world, puts computers into everything, rather than having this PC as a transition towards the real thing happening in computing in the future. I think even if you carried a really strong laptop around, it's like owning one important book, right? That's the idea. Even when you customize it or you have lots of them, you don't unleash literacy with that approach. So Ubicomp was trying to be a bit different, and multimedia was actually pulling this information even more into the computer. We talked about this, and there are some reasons that I mentioned. The compiling, as it's called in psychology, when the tool in your hand disappears, you don't think about the tool anymore. Heidegger's theories are behind that approach. Finally, the difference between this and VR is actually interesting when you think about it, because VR lets you actually explore unreachable worlds, which is great, right, inside an atom or on Mars. But it also tries to simulate every detail of reality. And that's really hard, right? As we know today, even the most modern VR systems cannot simulate all the details of the sight and smell and sound and haptics that you have in the real world. So for many cases, just augmenting the rich environment that we're already living in just makes more sense, right? It's more effective and more affordable and more economical to do. All right, let me move to the closure point here. So today, Ubicomp has actually become, oops, I went too far. Ubicomp has actually become a conference. Tabs, pads, and boards exist, but they're not plentiful in the sense that you're ready to leave them behind for the next person to use. But I do consider Ubicomp one of the most intriguing visions that we have for HCI and computer science in general. Weiser says, when you walk through the woods, there's tons of trees. It's a very complex environment, but you're not freaked out. It's not stressing you, right? But when you look at lots of technology, it does freak you out. So we want using a computer to feel as calm as a walk in the woods. I like that picture. Right, what's happening next? You're going to have some readings. The Computer for the 21st Century, the paper by Weiser that we just talked about here, and Bruce Tognazini's Starfire video paper. Those are required readings. And then also, if you're looking for a Christmas present to ask your parents for, I recommend Bill Mogrich's book, Designing Interactions. It's a great coffee table book. It's wonderfully made. Has lots of wonderful stories in there about how HCI came to be what it is today. You can actually go online, find like I think every month or so they release a chapter that you can look at for free, just to get an idea of how this book works. But that's a wonderful thing to add to your Christmas wish list if you're still looking for stuff. Then I have two resources that I can recommend. Bill Buxton, famous HCI researcher who came up with this long nose of innovation, the 30-year delay that we have in HDI innovation. He has a collection of input devices that is amazing. He has been collecting input devices for like, I don't know how many decades, and he's documented them all in this online collection here and talks about how they work and what's special about them. So this is really fun to poke around in if you want to look for funky input devices from from the past or from the present. The other thing that I literally just found last week is this curated collection of early HDI demo videos. It does have Put That There in there, but also lots of other videos, most from the ACM Digital Library, so you guys have access to these videos. But what this guy did, Jack Rusher, he actually took some of the most important videos and commented on them briefly and tells you what to expect from them and why they're important. So another great resource to get lost in if you're looking for some binge-watching material. In summary, we've seen the technology lifecycle today with these 4 phases and the sweet spot, and we've looked at a couple HDI visions like Put That There, the Knowledge Navigator, and Sun Starfire. We've briefly touched on VR and the World Wide Web just as directions that have also, of course, inspired today's user interfaces strongly, and then talked a little bit more about ubiquitous computing. With that, I'm going to wrap up for today. Thanks, everybody, for being here and joining us in class, and have a great rest of your week.
This content was provided by RWTH Aachen University.